Alright, today we'll be talking about operations with radical expressions. Now before you actually have to deal with anything, what you want to do is you want to simplify any radicals first. Okay, so that's hugely important that you simplify any radicals. Okay, now when you simplify, you want to pay attention to like radicals and unlike radicals, because like radicals you can add. So here's an example of some like radicals. Like let's say 3 root 7, that's a like radical with root 7. That's also like radical with negative 8 root 7. That's also like radical with pi root 7 or e root 7. Those are all numbers, as long as they have a radical 7 at the end, they're all like radicals. Now unlike radicals would be like something like this: 3 root 3, 7 root 2, or 7 root 7, root 6. Surprisingly enough, you can't simplify that one. And here's actually one of the larger ones that most people don't think like that. They're like, oh, you have to be able to simplify square root of 30, but you actually can't. It's 2 times 3 times 5, which there's no combination that's going to get you a perfect one. Okay, so just remember, simplifying, pay attention to the like radicals, and just remember, as long as you keep in mind that the radical is like a variable, you're going to understand this quite a bit. And we'll come back and talk about conjugates after we get done with the primary operations. Okay, so on this one, what we're going to do is we are actually going to simplify this second one. Okay, so this is going to become 3 times 2 root 5. Okay, which is just going to turn into 6. So this is actually simplifies to 6 root 5 because the square root of 20 is 2 root 5. Okay, now you don't see a number in front, but that doesn't mean it doesn't exist. There's actually 1 in front of those. So 1 root 5 plus 6 root 5 is going to be 7 root 5. Okay, so something simple as that. Don't change the square root, it's just going to make your job a whole lot harder. Okay, now the square root of 27 can be simplified into 9 times 3, and the square root of 9 is 3, so this would be 3 root 3. Okay, so 12 root 3 minus 3 root 3 is definitely going to be 9 root 3. Don't simplify any further and say, oh, that's the square root of 27. Nope, that doesn't make any sense whatsoever. Okay. All right, now, can this also work on multiplying? Yes, it can, because what you can do is you can distribute radicals. And you are going to, because we're going to have to learn that technique for conjugation. Okay. Now when you distribute radicals, you can multiply them as long as they're on the inside. So this is going to become the square root of 12 plus the square root of 18. Now if you recognize that you can simplify these, okay, this is going to turn into 4 times 3 square rooted. Okay, and 18 is going to become 9 times 2. Okay, and then you can simplify that even further. Okay, because you know the square root of 4 is going to be 2, and you know the square root of 9 is going to be 3. Okay, so this becomes 2 root 3 plus 3 root 2. Now, surprisingly enough, you cannot add those, but you can at least simplify it so that it's a lot easier to work with, okay? All right. Now this one, when you multiply 3 root 7 times 1 and 3 root 7 times root 7, that's going to be pretty simple. 3 root 7 times 1 is 3 root 7, and then that's going to be minus 3 root 49. But if you notice, the root 49 is going to turn into 7, so this just becomes times by 7, and then that becomes just 21. Okay, and I cannot subtract it because this does not have a root 7 on it, so I cannot simplify it any further. Okay, now hopefully some of you guys are recognizing that this is a difference of perfect squares. Okay, all right. So if we actually just multiply it out, it's going to be 4. Okay, so if we do FOIL or if we do the box method, okay, let me set up the box for you. Okay, so you can do FOIL or you can just set up the box. Okay, so this will get you 4. This will get you negative 2 root 10. This will get you 2 root 10. And this actually might save a lot of headaches later on. Now this one is going to be the negative of the square root of 100, which actually just turns into negative 10. Okay? And yes, you can square root a positive number and get a negative answer because there's a negative front, but you cannot square root a negative number. So let me just recap what I just said. You can square root something like this and get negative 7. That's okay because you square rooted the 49. But you cannot do this and get a real answer. It is imaginary, but I do want you to know the placement of the negative is very important. Okay, now here's the cool thing. These two are both the same except opposite signs, so they just cancel out. So what am I left with in this problem? I'm actually left with 4 minus 10, which equals negative 6. So I took something that was really complicated and simplified it down to one number. Okay, now on this one, this is actually squared, and I don't want you to just square this and then square this and be done. That means that you actually write this twice. Okay, so that's why I wrote it twice. I'm going right out the box so we can multiply it and so you can see it. Alright, so when we multiply these two, we're going to get 16 square root of 49. Okay, but we also know the square root of 49, which is going to be 7. So it's going to be 16 times 7. And let me multiply that real fast. Yes, I don't know that off the top of my head. That's 112. Okay. Alright, but then this right here is going to be minus 4 root 7. And this one right here is also going to be minus 4 root 7. Now, a lot of you guys are probably going, oh man, we can't simplify that. And you are correct. You cannot simplify those out to 0 because they're both the same sign. However, this is actually going to be a nice little positive 1 at the end. Okay, now the cool thing about doing the box method with multiplying binomials of radicals is that usually you can add diagonals. Okay, right? Alright, so I'm going to go ahead and do that, and that's going to be 113 minus 8 root 7. Okay, and that's what that actually turns into. Okay, just remember, don't just square the first and the last, just do that. Oh, now if you did see something like that, so if it was like 3 root 5 and it was just one term squared, you could do that, and that would actually turn into, you would square the first one, so that would be 9. Alright, and then the second one you're squaring, so it's root 5 times root 5, so that's the square root of 25, which actually just turns into 5. So this turns into 9 times 5, which is 45. Okay, so something as simple as that. Now let's talk about some conjugations. Alright, now on this one, I can rationalize denominator, but most of you guys are probably thinking, oh, I just multiplied top and bottom by root 5. Well, if you did that, you would get on top, so this would be 5 root 5 on top, pretty good. But then on the bottom, if I multiplied everything by root 5, this is going to be 2 root 5 minus 5, okay? Which is an issue because that is not rationalized. So multiplying by root 5 is not going to cut it. So what I need to do is I need to multiply by a thing called the conjugate. Okay, and the conjugate, I'm going to show you what it looks like. It's just going to be the same as the bottom, but with a plus with the opposite sign in the middle. So it's going to be 2 plus root 5, and it's going to be 2 plus root 5. I'm going to multiply the top and bottom by that. Okay. Now the cool thing is the conjugate is actually the other term here. Let's go back here. The conjugate is the other term you need in a perfect square, a difference of perfect squares, to actually get out, and so you wipe out the middle terms. Okay, so a conjugate is actually used, you've used conjugates before, you just didn't know it. You've used it in difference of perfect squares. Okay, so we're going to multiply these two, so that's pretty easy. So that's going to turn into 10 plus 10 root 5, so that's pretty simple right there. Now the bottom, here's the cool trick is with multiplying conjugates. It's going to be the same trick we learned over here. These two will cancel out. So technically, I only need to pay attention to the first two and then the last two being multiplied, and then I'm okay to go move on. Okay, so the first two is going to be 4. Alright, I know this is a difference of perfect squares, so I'm not going to have a middle term. So it's going to be minus the square root of 25, okay, which actually just turns into 5. And if you notice, that's beautiful because now I totally rationalize the denominator. So now on top I have 10 plus, oh shoot, that's not 10 root 5, that's 5 root 5. My goodness. Let's move this. That should be a 5. I just realized I made a mistake. Not the first nor the last, trust me. Okay, 5 root 5 on top. So that stays the same. Okay, nothing simplifies with that. And then on the bottom we're going to get a -1. Okay, now if you'd like to simplify, and I highly recommend it, just divide everything by -1 and you should be set. So this should be -10 minus 5 root 5. And voila, you've simplified by multiplying by the conjugate. Okay, now the conjugate here is going to be the same thing, except it's going to be the square root of 7 plus the square root of 3. And same thing on the bottom. Okay, the square root of 7, plus the square root of 3. Okay, I'm going to distribute along the top, and this is how fast it can be. Okay, so this on the top is actually going to be 3 root 7 plus 3 root 3. Okay, so that's pretty simple on the top. Alright, now remember I don't simplify that because those don't have like radicals. And then on the bottom, I'm just going to pay attention to the first and last. So root 7 times root 7 is root 49. Okay, and then it's going to be minus the square root of 9. Okay, now if you notice, those are going to simplify really fast to just 7 and 3. Okay, and then I can simplify the rest. Well, actually, I could just simplify it right here. 7 minus 3 is definitely going to be 4. Okay, and if you notice, I can't divide these top, and if you're trying to simplify, you have to simplify with these two, not the numbers inside the radicals though. And I can't, so I'm just going to leave it as is. Okay. Alright, so that's the operations with radicals and multiplying by the conjugate. And the conjugate is one of the most important parts you're going to need to know because it actually helps out with higher level math such as Algebra 2, pre-calculus, and calculus. So as long as you remember how to get the conjugate, and just remember it's the same as the binomial on the bottom except with a different sign in the middle, you'll be set. Okay, that's it for working with operations with radicals. I'll talk to you later. Bye.